sequences. So these are kind of a bit like patterns. Okay, so these are 3 things you can get asked. Number 1 is you can get asked to complete a sequence or find a value, like find the 10th value in the sequence, blah. Number 2 is you can find the nth term of the sequence, so this is finding the rule and like how you can calculate every single possible value of that sequence. And number 3 is it can give you a value and it can say, would this value be in the sequence? Okay, so let's have a little look at a sequence. 1, 4, 9, 16. Okay, so this is a classic example of a number 1 situation, complete/find a value. So it's saying find the next term. So we've been given a sequence 1, 4, 9, 16, and we want the next term. So we look at that and we think, well, what's going on? And we can recognise, this is one they often do, that these are all square numbers. The first one being 1 squared, this is 2 squared, this is 3 squared, this is 4 squared. So our next term here is going to be 5 squared. So the next term is 5 squared, which is 5, multiplied by itself, 5, which is 25. So that's an example of a number 1. We'll do another one. Okay, so here we have another one, but this is more of a picture-y one, and we've got squares. So it's saying how many squares in the 6th pattern. So this is again an example of number 1. We're finding a value. We're finding the 6th term in the sequence. So first of all, it's asking about number of squares. So we can kind of see we've got 1 square here, and then it's kind of increasing the space. We know there's 1 there, and there's 1, 2, 3, 4 in this one. 1, 2, 3, 4, 5, 6, 7, 8, 9 in this one. So again, we can see this is actually the same sequence, but as a picture, as could be chocolate bars, I don't know, at the moment. So we've got 1 squared there, 2 squared is there, 3 squared is there. This is the first term, second term, third term. So following this nice pattern, so the 6th term is going to be 6 squared, which is 36. So that's how many squares it's going to have, and it's going to be a bit bigger, so I'm not going to draw it out. Okay, so this is an example of a number 2 question, and this actually comes from an exam paper. So find an expression for the nth term of the sequence, and it's given us a sequence here. So it's important to understand that the nth term of a sequence is kind of the rule you can write down that will give you, if you substitute an n in, any term in the sequence, like forever and ever and ever. So first of all, we tend to look at the difference between numbers to work out, so we're just trying to figure out what's going on. It's a bit like a puzzle. So to get from 6 to 11, I have added 5. And to get to 11 to 16, I add 5. Right, so we've worked that out. That's kind of the hardest bit, but how do we actually write that down? And the way we do that for an nth term is we take this difference here, we put it as the coefficient of n, we do 5n. However, we are not done, because if we did our 5 times table underneath, so we do 5, so we do it as if it was just 5n. So this is what 5n would look like. You'd start at 5, so n is 1, 5 times 1 is 5, then n would be 2, you'd have 10, 5 times 2, 5 times 3 would be 15, 20, 25. So as we can see, if we just left our answer as this, as a difference of 5, these numbers should be the same. But this isn't the sequence we have, they're not the same. Similar though, so we can see that these are the same numbers but moved up 1. So 5 add 1 is 6, 10 add 1 is 11, 15 add 1 is 16. So we can see from our rule, we put the difference here, and then here is our add 1. So this coefficient of n, this is really important. This is the difference between our terms. We can't just leave it as that though, because as you can see, if it was just that, we'd have this sequence, but we don't, we have it shifted 1. So that's how we do it. If I wanted the 20th term of this sequence, without having to write them all down, I could substitute 20 in here. 5 times 20 plus 1, which is 100 plus 1. So I know it's 101, and that is so much quicker, and that is why we do this. Okay, so this is our next exam question. So we have this sequence here, 3, 7, 11, 15, 19. Part A says write down the 8th term, so we could just, 1, 2, 3, 4, 5, and then work out the next 3 terms. And then B says find the expression for the nth term of the sequence. So first of all, let's try and have a look at what's going on here. So I can go from 3 to 7, I add 4. From 7 to 11, I add 4. So basically I keep on adding 4, right? So we can see we're adding 4 each time. So I'm going to do part B before I do part A. So for the nth term of the sequence, we do the difference multiplied by n, and then we sort of like add or subtract some like the shuffle. So the difference here is 4, so we have 4 multiplied by n. But let's have a look at what 4n would actually look like. So if I actually wrote 4n, so I'm going to write 4n above. So that would start at 4, because 4 times n, when n is 1, is 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. So as we can see, that's what 4n would look like, but that isn't the same as these numbers here. So what has actually happened here, we have subtracted, so 4 to 3 subtracted 1, 8 to 7 subtracted 1, 12 to 11 subtracted 1. So you do 4n, the sequence, subtract 1. So now I'm going to go back to part A, and for the 8th term, n is 8. So you could write them out, continue adding 4, but I'm going to do it this way. So in my sequence, hoping that it's right, otherwise I'm going to mess up part A too, is 4 times 8 minus 1. 4 times 8 is 32. Subtract 1, which is 31. Okay, so our next example, so the nth term is 2n squared, so sigh of relief, it's actually given it to us here. A, find the 4th term, so let's just do A first. So this is a 1 question, so we're completing or finding a value. So we know our sequence is 2n squared. The 4th value means we're taking n as 4. So we're going to have 2. We're going to substitute our n as 4, don't forget to square it. So we've got 2 times 4 squared, which is 4, multiplied by itself, 4. 4 times 4 is 16, and 16 times 2 is 32. So that is our 4th term of the sequence. If we do part B, so this is now a 3-1, is a value in the sequence. So this is a bit harder. So is 400 a term in this sequence? This is how you would do a 3 question. And I think this is my only example of this, so try and pay attention. So is 400 a term in the sequence? What you do is you take your sequence and you equal it to this value here, okay? That's very important. You then solve, and then you ask yourself, is n a whole number? And if n is a whole number, it is in your sequence. If n is like a decimal or like point something and it's not a nice easy number, then that term is not in your sequence. So if you're asked if a value is in your sequence, you find your sequence, you might have to calculate it yourself, they might give it to you, you equal it to that term, and you solve for n. If n is a whole number, a normal, like, nice number, it is in your sequence. If n is not a normal, nice number, it's not in your sequence. So here, we've made our sequence equal the term. So now we're going to take the 2 over and do 400 divided by 2, because it's multiply on this side. We take it over here and it becomes divide. So n squared equals 200. So if it's squared on this side, you do the opposite, the inverse operation when you take it over. And the inverse operation of squared is square root of 200. Now, I don't know about you, but I don't think 200 is a square number. You can check it on your calculator, or you can write out square numbers, but n won't be a whole number. I'll tell you what n actually is. So n, if you actually type that in, but you don't really need to, you can just write out all your square numbers. It's something like that. Now that's not a whole number, that's not an integer, that is not something you just naturally write on your number line. So therefore, 400 is not in the sequence.